Hello and welcome to another tutorial. My name is Edgar Santiago. I'm a CCNA certified. In this lab, we're going to work with Spanning Tree Protocol advanced features. We want to work with PORTFAST, which is one of what we learn on the CCN or CCNA studies. Also, we're going to work with BackboneFast, UpLinkFast, ROOTGUARD, and BPDUGUARD. Right now, I have this small topology, which is composed by three switches. The switch 1 is a root bridge, and by default, as we know from the STP basics, all the Cisco switches has the default priority, which is 32.76.8, and right now I can figure I configure this switch to be the root bridge by using the command spanning tree root primary, spanning tree VLAN1 root primary, because we need to specify which VLAN we want to affect. And right now we don't have only in this video we only have VLAN1 configured in this. So if we use show VLAN brief, we can see that all the ports are in VLAN1, and we have the legacy VLANs, and we are not work on that. So right now, if we use the first command that we need to know, and it's very useful for a lot of troubleshooting, and also for the XM, is show spanning tree VLAN1 in this case, and we can see a lot of information, very useful information. The first line that we have is specifying which type of spanning tree protocol we are running. By default, in all Cisco switches, we are running per VLAN spanning tree, which means that we can have a multiple spanning tree, and it's going to be one spanning tree per VLAN, and that's why we have that word per VLAN spanning tree. Also, the other information is this one. This information is regarding with the root bridge. So the root ID, as we can see, we got the priority, which is the lowest than the default, and that's because for the command I used before, behind the scenes, before we start this lab. And also we have the address, the MAC address of that root bridge. And if we compare this address to the information for the bridge ID, we see that the number are the same, and that's telling us that we are in the root bridge. Another way to find out if we are on the root bridge is with this beautiful message saying this bridge is a root. And another way also to see if we are on the root bridge is because the port Ethernet 01 SW1 and the port Ethernet 00 are designated and forwarding, so it's forwarding packets right now. It's forwarding and receiving packets right now. So we got also the hello time to refresh from the CCNA studies. The hello times is how often the root bridge originates configuration bridge protocol data units. And bridge protocol data units is the way that we can that STP works. Is the way that the SW1 is telling all the neighbor switches which is the root bridge and which has the lowest priority. And right now, to also refresh for the CCNA, the election of who wants to be the root bridge is by identifying the switch that has the lowest priority. But if we have a tie in that, then the switches will look by the MAC address with the lowest MAC address. And take note that the MAC address is read from left to right. Okay, this is the basic information. The max H is 20 seconds, and that's mean how long the switch will retain a superior BPDU before discarding. And also we have the forward delay, and the forward delay is the length of listening and learning port states. And this is the default parameters that we have when we are running STP. Also, I'm going to enable on switch 3 because we are going to work a lot in this lab with switch 3. I'm going to enable on that guy the debug command show spanning tree event, and that's will giving us a lot of useful information when we are moving from the states, from listening to learning to forwarding, etc. Also, when we work with ROOTGUARD, BPDU Guard, and BPORTFAST, it's good to have unable to see what's happening in the background. The debug command, debug spanning tree root. With those two commands, we can see a lot of information and we can understand better how spanning tree works. So the first feature that I'm going to work is with PORTFAST. PORTFAST allows a port to run in STP to go directly from blocking to forwarding. And that's because if we don't have PORTFAST right now enabled on the interface Ethernet 1.0, that port will take 50 seconds to finally allow to that host to forward frames in the network, or also forward packets, doesn't matter. So when we enable PORTFAST, that port is going to transition almost immediately from blocking to forwarding. So I'm going to leave that PORTFAST away right now from the port Ethernet 1.0, so we can see how much this takes, the STP states takes to allow that host to forward frames. If I use the show IP interface brief, we can see that the Ethernet 1.0, which is this one, is administrative down, so I turn off manually. I'm going to turn off that port because if I check the show MAC address table, we can see that we don't have any entries of the MAC address of this guy. And if I go to that port, to that host, and show IP, we can see that the MAC address for the interface of that host is this one. So we don't have 0050 79 60 66 68 00 on the entries in the MAC address table on SW3. So by going to the interface Ethernet 1.0 and turn on that port, not shut down, with the debug command that I enabled before, we see that the port is assigned to VLAN 1, and the first state is listening, which is the second state because 1 is blocking. So it took 50 seconds to transition from listening to learning. And when we are listening, we can listen and send BPDU to participate in the lection, but we cannot forward packets or frames. When we are learning, also we are send and receive BPDUs, and also we are learning the MAC address for the neighbors. And the last step of the spanning tree states is the forwarding, which we can send and receive BPDU, and also we can forward finally frames or packets. So this took almost 30 seconds without count with the blocking state. So I'm going to turn off that interface again. I'm going to turn that interface again, and also I'm going to check the do show MAC address. We don't have nothing in the SW3 right now, so I'm going to enable that feature PORTFAST. And as we can see, we got the warning message saying that PORTFAST should only be enabled on ports connected to a single host. Connecting hubs, concentrators, switches, bridges, etc. to this interface when PORTFAST is enabled can cause temporary bridging loops. Is with caution. So another useful information is that Ethernet 1.0 will only have effect when the interface is in non-trunking mode. We cannot, or we should not, enable PORTFAST on trunk modes because we will end with a lot of mess, a lot of broadcast turns, a lot of back and forward frames that never ends. We want to end in a loop, switch loop. So Right now, I got the 23 port fast enabled. I'm going to turn on that port again to see what happened in the background, sorry. So not shut down. And this message is very great. Jump to forwarding from blocking, and that was almost in a second when I turn on that interface. So that's all about PORTFAST. We enable PORTFAST on ports that are an access port and belongs to only one VLAN. The next feature that we want to work is with UPLINKFAST. And UPLINKFAST permits us to speed up the length that STP state takes between switches. It applies globally for all VLANs. One of the thing that happens when we enable UPLINKFAST is that it's going to raise that switch priority to 49,152, and also it's going to increase the cost of the link by 3,000. And that's because when we have the priority, a higher priority, and also a higher cost, we're making sure that this switch is not becoming the root. So it makes sense. It does make sense. So what is UPLINKFAST? To be honest, to tell you the truth about this, UPLINKFAST is like a PORTFAST, but for links between switches. That's all. So we have to configure or enable that port, that command globally. We cannot use UPLINKFAST for, let's say, I want UPLINKFAST for VLAN 1 but not for VLAN 2. No, that's not how it works. We need to see, if we want to enable UPLINKFAST, all the VLANs that are part of that switch are going to be affected, okay? So show spanning tree UPLINKFAST is the command to enable this UPLINKFAST. And done. We're done right now. We're done right now, and we see the information right now. Setting bridge ID, which is equal to 1, priority 49,153 plus we are the VLAN number, which is VLAN 1, and that's because we need to sum the VLAN number plus the priority that we have. So it's 49,153. But the default when we enable the UPLINKFAST, as I say before, is 49,152. Also, we got when we go to the do show span VLAN 1, we see that the cost of the links turned to 3,000 plus the cost to reach the root bridge. So right now, the root bridge is SW1, and the port that are connected to the root bridge, the role is going to be the root, and that's telling us that by this port I can reach the root bridge, and also I'm forwarding frames to that port. On Ethernet 01 also we have designate forwarding on SW3, and that's why is that? I don't know why is that. Let me check again. Designate forwarding. Something happened maybe because it's not supposed to be forwarding right now. It's supposed to be in blocking mode. So I'm going to, maybe I forgot to turn on the interface Ethernet 00. So show interface IP, you should say IP interface brief. And that's why we have the Ethernet 00, Ethernet 01 on SW3 enable forwarding and designated, because this link on SW2 is turned off by right now. So I need to turn on that port to make the correct decision to block the corresponding port. Right now we don't have any loop because the Ethernet 00 is turned off. So we're going to move to the SW2. We're going to get in the global configuration mode, interface E00, and we're going to enable that interface. After that, if I do show spin in, we see that the Ethernet 01 is alternate blocking, and that's what I expect. And that's because if this is the root bridge, the link from the perspective of SW2 to SW1 need to be in root designated, because that lane is the path to reach the root. And also, as we saw before, the Ethernet 00 also is root forwarding. So I can guess that SW3 Ethernet 01 is the port that's going to be blocked, because the cost to reach the root bridge by this way is going to be highest than this way. And that's because we need to zoom the links, and if this link costs 100 and this is 100, we got 200 cost plus the 3000 that we have when we have enabled the UPLINKFAST. So right now I have this show span VLAN 1, and we see the correct information. We got the Ethernet 00, which is root and forwarding, and we have the Ethernet 01, which is the worst path to take communication to SW1, is in alternate blocking, and that's how STP works. But what happens if I disable the port on SW3, the Ethernet 00, which is the shortest way to reach that root bridge? So if I disable that, it's going to take me 30 seconds, 50 seconds, 30 seconds to reach and recalculate how I can reach that guy, the SW1. So with UPLINKFAST, we can transition almost immediately from blocking to forwarding, and the Ethernet 00 is going to be discarded because that communication doesn't work, and the Ethernet 01, you need to go from alternate blocking to root forwarding. So let's find out. Interface Ethernet 00 shutdown. And as you can see, we got a lot of messages here. And the first one is spanning tree fast 7 port forwarding uplink. Ethernet 01 move to forwarding, and then the feature that we enable, UPLINKFAST. And also we add here Ethernet interface. This is a very a normal message when we turn off a interface. So when I check right now, almost quickly, show span VLAN 1, we see that the port Ethernet 01 is the guy to hold the path to reach the root bridge, but the cost increased, and that's normal because we got a 100 link, because these are Ethernet ports, and the Ethernet ports, the cost is 100. For fast Ethernet ports, the cost is 19. For 1 gigabits, the cost is 4, and for 10 gigabits, the cost is 2. So we have 3,200, and that's great. So I'm going to enable that port again. Conf T interface Ethernet 01 00, just say, and I'm going to turn on that guy, not shut. So right now we got a lot of information back and forth. We got the listening of the states, we got the blocking, and that's because we have the UPLINKFAST enabled on this switch. So show span tree, you can see that the Ethernet 00 right now is blocking, and we need to wait almost the 30 seconds to now recalculate. The switch is not making a bad decision to enable that back right now. So almost 30 seconds, the UPLINKFAST works again and telling us that the explanatory fast port forwarding uplink on Ethernet 00 moved to forwarding UPLINKFAST. So the STA, the spanning tree algorithm, determined that the cost to reach the root bridge the best path is Ethernet 00. So that's why it took 30 seconds, from 50 to 30 seconds. So another command or feature that I want to share with you guys is the backbone fast. The backbone fast recovers for indirect links failures. Backbone fast speeds up the overall process by skipping the max H stage. It calls the overall delay from 50 seconds to 30 seconds. So if you forgot the maximum age, that is how long the switch will retain a superior BPDU before discarding. So that is 20 seconds. So right now, the key of backbone fast is indirect links. So if we enable backbone fast of SW3, neither Ethernet 00 or Ethernet 01 are indirect links because they are direct links. So indirect links might be this guy, Ethernet 01 from the perspective of SW1 and Ethernet 00 from the perspective of SW2. So I'm going to enable backbone fast on SW3, spanning tree, backbone fast, and right now, if I turn off this interface, this switch is going to receive BPDUs from SW2, and it's going to tell him to SW2, hey man, I'm the root bridge, I'm the root bridge. And SW2, which has the lowest priority, it's going to say, hey man, I'm the root bridge. So with backbone fast, we're going to cut that process from 50 seconds to 30 seconds. So I'm going back to the SW2, and we are on the internet. We're going to the internet interface 00, and I'm going to turn off that port. Shut down. Now I'm back to SW3, and we see information regarding with the backbone fast. And we see that VLAN 1 had root 32,769, which is the default priority plus the 1 VLAN, and it's listening BPDUs right now from the SW2. For in the end of this, the Ethernet 01 is listening, and also topology change received on Ethernet 01. So right now SW3 thinks that the SW2 is the root bridge, but we need to wait a little, and we have right now a great information. VLAN 1 sent topology change notice on E00. VLAN 1 Ethernet 01 forwarding. So I'm going to check that show spanning tree VLAN 1, and you can see we have yet the same root bridge, which is the SW3, because it has the lowest priority, I said manually. And also we can see that Ethernet 00 stays on root row, because this is the short way to reach to the root bridge, and it's forwarding. And also Ethernet 01 is designated forwarding. It's not blocking because we don't have a redundancy right now, because we disabled this port. So it's all about backbone fast. The other command that we have here is the ROOTGUARD, and the ROOTGUARD is configured at the port level, and it disqualifies any switch to become the primary or secondary root. When a superior BPDU is received on a port running ROOTGUARD, that BPDU is discarded and then port put into root inconsistent state. So this command is running on the interface level. So I'm going to run that ROOTGUARD between this rogue switch, who has a lowest priority. It's going to find out show span, and it has a priority of 1. So if I don't have right now a ROOTGUARD between the links on SW3, this guy is going to be the root bridge of this network, and that's not good, because if this is a route switch, we got big problems. We got big problems. Well, because we are now out of control of who is the root bridge by a malicious attacker in our network. So I'm going to connect that guy. I'm going to enable first the command on SW3 conf t the show IP interface brief. Let me think. I'm going to choose Ethernet 00 to assign that feature. So interface Ethernet 00. Oh no, Ethernet 00 is the link between SW3 and SW1. Ethernet 01, Ethernet 02. This guy doesn't have nothing. Ethernet 02. So I'm going to enable spanning tree guard root. We enable that right now. So from this guy to Ethernet 02, let's see what happened. And that port is down right now, but it's not administrative down, right? Show interface Ethernet 02, and you can see that port is in error disabled state. And that's why, let's find out. Show conf t interface E02 shut and not shut. Let's go to reboot that port to see what happened. Okay, we got the message that we wanted. Right now, we're going to have each 2 seconds the information that that port is in root inconsistent state. I'm going to turn that port again off, because we're going to feel overwhelmed each 2 seconds with all this information. So I'm going to shut that port down, and we're going to read that messages. So the first one we have here is third priority VLAN 1 Ethernet port 02. Also get the spanning tree is in listening, and when we are in listening, we are listening BPDU packets. So when he listen, the SW3 listen BPDU from the route switch on the SW2 route switch. We got a hard root, and we got that switch supersedes the root guard, the root bridge, which has the priority ID of 24,577. So the last thing that the root guard going to do is going to block in that port and put in a consistent state. So if I'm going to that port again, show interface Ethernet 02, sorry. Right now we got the port disabled, but I'm going to enable that port back to see the message here. Interface Ethernet 02 and not shut to turn on that guy. The spanning tree going to listen that guy, and once he notices that the bridge protocol data unit is superior, is going to put that port in a consistent root state. So I'm going to again to the information to say interface, and we see that the port is not turned off, and that's because that port is going to how can I say, that port is going to be running until we have a decision to turn off that port, or to, if we know that switch, so that switch is not the rogue switch, that switch was a spare switch that we have in storage, and we forgot to change the priority number. So we can, right now we can also go to that switch, route SW2, and we can configure the switch so it can have a default priority number, and we can see that we are stop this information. So if so spanning tree VLAN1 priority, I'm going to say 1, and I'm going to put, I don't know, 49,000. I'm going to paste that number here. To N, show span VLAN1, and we see that this switch before was in priority of 1, and if we go to the SW3, we don't have any message regarding that this switch has a lowest. As you can see right now, ROOTGUARD unblocked that port. So ROOTGUARD unblocked that port because the priority number of that BPDU is not superseding the priority number of the root bridge. So that port is going to need to pass to learning, listening, and then forwarding to make sure that we don't have any loop. So we got also the BPDU Guard, and I prefer this guy over ROOTGUARD, and it's because BPDU Guard turn the port into error disabled state. So that happens when any BPDU is receiving, can be inferior BPDU or superior, and this is great to apply on PORTFAST, and can be applied on a port level, or we can apply also in globally. So I'm going to put that guy in globally. So command is global spanning tree BPDU spanning tree PORTFAST and BPDU Guard, BPDU Guard. Right now we are applying this in the global configuration mode. So if we go to the running configuration mode, we will see that all the ports that are not running trunk links are going to be in BPDU Guard enable. I think we got use show spanning tree summary. We can see that we got PORTFAST, BPDU Guard default is enabled, UPLINKFAST is enabled, BPDUGUARD is enabled. I got a lot of information here. So I'm going to put this guy, which has this is the SW. This guy shows span, and this guy has a lowest priority number than the root bridge, pardon. So I'm going to connect that guy to one of the ports in the 1.1, and let's see what happened. So as you can see, we have this VLAN1 herd root priority number 8193, and we can see that it supersedes the priority number of the root bridge. So if we see this information below, we need to wait a little because it's in learning mode right now. And you can see right now we have this message. When it's in listening mode and listening can send and receive BPDU guards, BPDU information, when he noticed that this port was in, that this switch has a lowest priority, he's going to turn on that interface, turn off that interface, so it stays down. And how we know a port that is in error disabled state is going to be turned off until we fix the thing, and we need to reboot that port. So we need to not shut down to again back that port up. So if we go to the show interface Ethernet 1/1, we can see that that port is running, connected. It's supposed to have error disabled message here. I don't see that. Also, I'm going to show spanning tree. Also, we didn't configure that BPDU guard correctly because right now the rook switch is the root bridge, and we don't want that. Okay, so I'm going to turn off that interface. Ethernet 1. I'm going to show that guy, and maybe this doesn't work. This didn't work because we are running a virtual environment, and these are a experimental iOS running on Linux OS. So I'm going to put that command in the port level. Conft interface Ethernet 1.1 spanning tree BPDU spanning tree PORTFAST spanning tree BPDU Guard enable. So I'm going to check if the root bridge SW1 is the root bridge, so spanning tree, and we got back the root bridge, the SW1 as acting as a root bridge. So I'm going to turn on that port again. Interface E11, and now shut to turn on that guy, and let's see what happens. Okay, perfect, this works. Spanning tree block BPDU guard receive BPDU on port Ethernet 1.1 with BPDU guard enabled, disabling port. We got the next message, error disabled, BPDU guard error detected on Ethernet 1.1, putting into error disabled state. And then that interface is shut down. We can go to the show interface Ethernet 1.1, and we can see that that interface has the message error disabled states. So to fix this, we need to resolve the issue on the rogue switch in case that switch is owned by the company, and then shut and non-shut down that interface to get that port back again. So well guys, that's all for now, and I hope you enjoyed this video, and let's see if I can make another video in the future about this technologies. See you.